Hey friends, MoNaCo here. Last video in the unit, percent error. So percent error, you're going to understand that there's error associated with every measurement, and you have to be able to calculate a percent error compared to the accepted values using a reference material. Okay, so that's what today's lesson is about. What is percent error and how do we calculate it? In science, we make tons of measurements all the time. Mass, length, volume. Every measurement has a little bit of human error in it. Maybe I didn't read it right. Or, in fact, when I set it up on my scale, maybe it fell between two lines on the measure, so there's some error in it. Every measurement contains error. When you calculate your results, you always want to compare them back to what's accepted. So there's reference for these materials. You always know what the density, mass, volume, length, etc. of something might be, so you always want to compare your results to the standard to see how good you were, to see if you need improvement. Okay? By studying error and eliminate it where we can improve accuracy and precision, which is something that we scientists are very concerned about in our labs. Okay? So, percent error. Basically, it's the measurement of the percent that a value is off from an accepted. Measured value is what you got in the lab. You measure the density of gold to be blank, X, Y, or Z. The accepted value is what you should have gotten. So like what the textbook says the density of gold would be, which is Y. So you got X, you should have gotten Y. How far away were you from the accepted value? Here's the formula that you're going to find on page 12 of your reference table. When we get those printed, it's the last page of your reference, and there it is. Plug in and chug in. So if you get a negative result when you do a percent error calculation, it means that your value is less than what you should have gotten. You were underneath. So the negative sign tells you were underneath. If you are getting a positive value in your percent error calculation, it means you were above the accepted value. You were higher than you were supposed to be. It's very important that you put the given values in the proper place in the formula. You don't want to do accepted minus measured divided by accepted because you're going to get the sign wrong. So you're going to find that your value is reporting to be larger than it was supposed to be when in fact you were really smaller. So just a little bit of care when you're setting up your problems goes a long way. Ounce of prevention, more valuable than a pound of cure. So you always have to read these questions very carefully because I almost made a mistake myself when I did this a moment ago. So in a lab experiment, you're told by your teacher that the actual accepted amount of sugar in a can of Coke is 39 grams, and you experimentally determined to be 40 based on your own data and calculations. What's your percent error? How far away were you from the accepted value? I'm going to use abbreviations here. So percent error equals, let me just double check. I want to make sure I plug it in right. Measured minus accepted over accepted. So I'm going to do M for measured minus accepted over accepted. I do remember you multiply by 100 to turn it into a percent. So I look back to my problem. The actual, which is accepted amount, is 39 grams. And the experimentally determined, which is the measured amount, to be 40. So I know what values I have, and now I know I have to plug them in. So percent error is going to be my measured 40 minus 39 divided by 39 times 100. Now, that turns into percent error equals 1 over 39 times 100. So I pull out my trusty calculator. Hello, iPhone calculator. Hey, Mr. MoNaCo. 1 divided by 39 times 100. So I'm getting the calculator barf of 2.5641026%. Now, the last little bit about this problem says, what's your percent error? Express the answer to the proper amount of significant figures. How the heck can we take two numbers that were small, whole numbers, and get this from it? We have to condense that big old number with 3, 6, 9 significant figures down into something a little bit smaller. Since we only have 2 significant figures in each case, we are only going to report this to 2 significant figures, which rounds to 2.6% error. Okay, so that's really it. That's percent error. Plug and chug. Calculate percent error for measurements using the standard equation. You should be able to do that now. Here's the standard equation registered for you on your reference tables. Again, the hardest part is reading for comprehension on your problems. What's the accepted value? What is the measured value? Plug it in and chug it in correctly. If you do not understand this little bit about significant figures, please be sure to go back and watch one of my other videos regarding the issue. Okay? Thanks so much for watching. Have a good day.